Hi. So in this video, I want to show you how to connect to a local development instance of Kubernetes. Some of the feedback that we've heard from people using Kubernetes for the first time is that it can be overwhelming to understand where to start. There are a number of tools out there that allow you to run local clusters. It's quite often hard to find a reason to pick one over another. And so in this video, I'm going to use a tool called Kind to create a local development cluster and then connect that to a cloud-based instance of Octopus. The reason why I like using Kind is that it's very quick to create the clusters and it integrates very well with WSL2 because, as we can see here, Docker Desktop for Windows integrates quite closely with WSL2. So I've enabled this option here, use the WSL2 based engine, and then I have integrated that with one of my WSL2 instances. And in this case, that instance is Ubuntu 20.04. And so we can see that integration here. So I'm in my Ubuntu WSL2 instance. And if I run a Docker command, I can do so. And so we leverage this to allow Kind to create our test cluster within WSL2 and simulate a Linux-based development workflow from Windows. So the first thing to do is to download and install Kind. That is done with these two commands here. I've already run these two commands, but this curl command will download the executable, and this one here marks the file as executable so we can interact with it from the command line. And so to create a cluster, you run the Kind create cluster command. And so this command will download the control plane image, which in my case is version 1.18. We'll deploy that to Docker and then configure the cluster for us. And this usually takes less than a minute actually to create a fully functional local cluster for us. So we'll see very shortly that the last couple of steps will complete and we'll be ready to start interacting with the cluster. And there we go. So that is done. So what we now have is a local Kubernetes cluster, and we can see that through the config file that Kind created for us. Through the config file in the .kube directory of my profile. And so this config file has a certificate that we need to use to trust this self-signed HTTPS endpoint, and it then has a user that is identified by a certificate here and then a private key here. And then we can just use kubectl to interact with the cluster. So I'll run the get nodes command, and as we can see, our cluster has one single node ready to go. So the next step is to connect the development machine up to the cloud-based instance of Octopus. Because my development machine doesn't have a static IP address, the hosted Octopus instance can't reach into my machine. So what we'll need to do is use a polling tentacle, which initiates a connection from my machine back out to Octopus. And in that way, a machine without a static IP can interact with Octopus. So to install a worker, we need to install the tentacle application. Because my WSL2 instance was based on Ubuntu, I've used these instructions here. And I've done this prior to the video, so I've just copied and pasted to install this application here. And so to set up a worker, I'll need to run this configure tentacle script, and I'll need to run that as root. So the name of the tentacle is fine. I will need to do polling here because I need my machine to reach out to Octopus rather than the other way around. These directories are okay. The server URL in my case will be this address here. I do want to authenticate via an API key. I will just paste that in. You won't see it on the screen though. And then we do need to select worker, which is option 2 here. Now the space that I want to use is called Kubernetes blog 1. Blog 1. That name is fine. I have a worker pool called Linux here that I will place this worker into. And we're all good. So the downside to using WSL2 is you don't get access to systemd. You can't run anything as a service, not easily anyway. And so you will see this error here about not being able to start systemd. But that's okay because we can just run it manually using this command here, which we will also have to run as root. So the instance name here of Tentacle is the same values that were used to configure the Tentacle. And it's established a connection and we are all good. So we should now see that here, and that's my worker. Okay, so with a worker established, I'll just open another session here to my WSL2 instance. Zoom in a bit. And what we need to do now is configure a target in Octopus to point to the local Kubernetes cluster that I created with kind. And to do that, I'm going to need to take the values from my kubeconfig file, which is this one here, kubeconfig. I have to take these values and convert them into formats that Octopus can use. And specifically what we're going to need to know is this address here. And we're going to need to bundle both this certificate and private key into a PFX file so we can upload that to Octopus. And then we'll need this, this certificate here as well. And so to do that, the easiest way to do it is with a little script that calls OpenSSL. And so if I look at bin, and then it's cert. So this is the script here. And what this is going to do is use the config view command, which outputs this same config, but in a JSON format. We'll use WQ then to extract the various fields that we were interested in. So this is the certificate, this is the private key, and this was that certificate that we needed to trust the HTTPS endpoint. And so we'll save the user certificate and key to these two files. Then we use OpenSSL to create the PFX file. We'll clean up these two intermediate files and then also write out the certificate that we use to trust the cluster API endpoint. And so if I run this file, actually I'll just go into my desktop directory and then I'll run this. And so you can see then the files that we expected to be output. This is the PFX file that was created here. And this is the cluster certificate that was created here. And so now we need to upload those into Octopus so we can make use of them. So if we go here, and I'll just zoom in a bit, and we go to certificates, we will add a certificate, and in this case, we'll call this the kind user certificate. The file is going to be the PFX that we created, and it has no password. So we'll just save that. And as you can see, the file has been uploaded successfully. If we go back here, we get some details. So the next step we need to do is upload the kind CA certificate. And to do that, we will select the cluster certificate. Again, no password. I believe I didn't base 64 decode that. Okay, so what happened here is these values are actually base 64 encoded. So what I need to do is go into cert. And what I need to do before I dump that out is to cert 64 decode. So you can see this, if I copy and paste this code here, That's the decoded value that we actually need for that file. So I'll just run that again. So cert.sh, that will overwrite the files. Let's try that again. Pick the file. Yep, there we go. So that's worked. And again, we can see the details of that certificate here and the fact that it's self-signed. So what we now need to do is set up the infrastructure. So if I go to deployment targets and select Kubernetes cluster, call this kind. This will go on my dev environment. It will have a role of Kate's. And we're going to use a certificate to authenticate to this cluster. And in this case, it's going to be the user certificate. And that was the PFX file that we uploaded. We then also need the URL. And so the URL was, if I go cat kube config, that's this URL here. And so remember, this address is relative to the worker that we will use to connect to that address. And in this case, the worker is running on localhost, running alongside the local cluster. So we use this localhost address here. The certificate here is the CA to trust this self-signed HTTPS. And in this case, we do want to use the Linux worker pool to establish connections to the cluster. So if I save that and go to the connectivity and check the health, we'll see Calamari being downloaded and extracted to my tool, my local development machine. And once that completes, the health check will go ahead. And there we go. So we have successfully completed a health check and returned the version of our Kubernetes cluster. So with the target done, we can now start deploying something to this cluster. And so I have an empty project here that I'm going to use to deploy just a standard Nginx container. But before we do that, actually what we need to do is set up an external feed. So external feeds allow us to select the particular version of a container during deployment. And in this case, the container that I want is just hosted on Docker Hub. And so these values have all been set up by default. My browser has put in some credentials here that we don't need, so I just need to delete them. If I go ahead and test that, we should be able to see that it returns the container that we want to use. So if I go back to my project, I will use the deploy Kubernetes containers step. So this is a UI-driven and opinionated step that is useful for getting up and running quickly with Kubernetes. And this builds up a deployment resource on our cluster. In this case, we need to run this step on the role that we assigned to the Kubernetes cluster, which is K8s. I'll call this my deployment. All the values here we'll leave as defaults, and we will need to define the containers, or the single container that we place into the pod that is managed by our deployment. And so we'll just use Nginx here for this one. And that's the container there. So we do need to expose a port to allow traffic in, and that's port 80. And that's all we really want to do here for this particular container. And that's it. So that's about as minimal a configuration as we can get. So we'll save that. And we will go ahead and create the release. So you can see here, I'm given the option to select the container version during deployment. So this is one of the advantages of using a tool like Octopus. When we were building up the deployment resource, we selected the image, but not the version, because we expect the overall deployment process to be very static, but the versions here will change as you release new versions of your own software. And we will deploy to dev and just push that through. Okay, so what we will see, if I go into verbose, to the verbose logs, we can see the actual YAML resource that Octopus has created for us. And that's this deployment resource here. And as we can see, it has created the Nginx image, sorry, the Nginx container for us and exposed port 80. So if we go back to here in WSL2 and we run pods through kubectl, we will see that our deployment has created a pod and that pod is now running. Now, one of the tricks with Kind is that it doesn't expose a lot of ports. The only port it really opens up is the API port. So that was the this port here. But what you can do is use the port forward function in kubectl to take any free local port and then push that through to the Kubernetes cluster. But to do that, we're actually going to need to have a second resource created to expose that deployment, and that resource is called a service. So a service exposes pods to either internal traffic or external traffic. I'm only obviously developing locally, so I only need internal traffic. So we'll just use like the cluster IP option here. If you were exposing this publicly, you could use node ports or load balancers. Those are a little bit more advanced though, so we won't go into those. And again, we're just exposing port 80 on our Nginx container. So we'll save that and create a new deployment. And again, if we look at the verbose logs, we can see the resources that were created. It's gone through and recreated that deployment. Nothing has changed, so Kubernetes would be, generally wouldn't change anything here, but it's also deployed the service. And in this case, we've created a cluster IP that exposes a port called web on port 80 to any pods that have a label that matches this. And so you'll see this, this label here is actually one of the labels that is created on the deployment, and more importantly on the pods created by the deployment. So that is that one there. If we go back to our WSL2 instance, kubectl services, we should see now that the service we created is now active and exposing traffic. But again, yeah, we still can't get direct access to that just because of the way Kind works. It doesn't expose those ports neatly for us. So what I need to do is use that port forwarding command. So what I will do here is forward any traffic from my development machine on port 8081 into the cluster on port 80 to this service here. And that was a service we just created. So that port forwarding being active, we can go into the browser, port 8081, and we have Nginx. So we have successfully deployed both the Kubernetes deployment and service resources, and the port forwarding is working, allowing us access locally, and we can use that for local testing or development. And that's it. We now have a complete workflow for interacting with a test Kubernetes cluster from Octopus down through to a Linux instance being hosted by WSL2. And we could now create additional environments. And so if I go here, I've had the dev environment. So I'll simulate a multi-environment deployment here on my test development machine. And typically the way we do that is actually have multiple targets. And so what I'll do is create a new target that copies the IP address of my kind cluster. So let's go ahead and create a new one. Let's call this kind test. This will go to the test environment. Again, we'll use the k@s role. Client certificate, same as we used before. Cluster URL, same as we used before. And the certificate authority is the same. What I will do here is change this default namespace. And so what you would typically find in a real world production deployment scenario is that the user that you're configuring against the target would only have the rights to one particular namespace. We've used an admin user here just for convenience and a quick demo. But yeah, typically there would be different users for each target, and those different users would be restricted to an individual namespace. And so what I'm going to do here is create the test namespace as the default for this target. And so what that means is when deployments are progressed to this target, they will be placed into the default namespace of the target. And so with this here, we can do a health check. Obviously it was just green, so it did work, but we can manually do it again. There we go. And let's progress this through to the test environment. And there we go. Deployment went through quickly. I will just cancel that port forwarding. We'll get the pods in the test namespace. And so here you can see that I've returned the pods from the new namespace, and here are the pods that represent our deployment to the next environment. So that was all I wanted to show. Hopefully you can see now that it's fairly easy to get up and running with Kubernetes for local development using a tool like Kind. And thanks to the ability of polling tentacles to reach out from a development machine into a public instance like the one we have here, hosted in the cloud, we can also interact with that directly to simulate our deployments. Thanks for listening, and all the details for the sample scripts and links to various pages will be in an associated blog post. So thank you.